Hello there, welcome back. In this tutorial, we are going to learn how to make Cheevos from scratch, step by step for complete beginners. The core focus of this video is to understand flags and operands, which are essential concepts you need to grasp before diving into creating achievements. The video is split in two parts. In the first part, we'll go over flags and operands and explain how they work. In the second part, we will get hands-on and build Cheevos under different practical scenarios. But first, let's learn how to create a Cheevo. Over here in the toolkit, this window in the asset list, it holds all your assets, achievements, leaderboards, and rich presents, and it lets you manage them. From here, you can control everything you've created. Now, you'll notice this drop-down menu. It displays the state of each asset. For example, my achievements are currently in the unofficial state. That means they are ready to be promoted. If I hit promote, they will go to core, making them live for everyone to play. And at this point, I can complete my claim. However, only full developers and code reviewers can promote or demote achievements. If you are a junior developer, you can only push assets to unofficial and then wait for a reviewer to promote them. On the other hand, leaderboards and rich presents don't actually require promotion. You can create and push those to core instantly without waiting for a reviewer. Alright, now to create a new achievement, make sure you are in the achievements category and just click the new button right here. This creates an achievement locally. Once you do that, the asset list will jump to the local category, meaning you are now working with achievements saved only on your machine. Give it a short name and a description. Beautiful. Now that we have a dummy Cheevo created, let's talk about how conditions work. I have a game running here, but to keep things simple for now, I'll use manual variables instead of actual game variables. It saves us time and keeps things focused and intact. This one right here is a variable. It might represent like health, score, etc. I'll add it by clicking the new button in the corner of the Cheevo editor. Now this isn't a real in-game address. I will just tamper the memory in real time to show you how the conditions behave when added. Once we add this address, it becomes a condition. Let's now focus on the size and value columns. When an address doesn't have a code node describing its size, the Cheevo editor will automatically assign the size based on your current memory viewer mode. For example, if your viewer is in 32-bit mode and you add the address, it'll be treated as 32-bit. If you switch to 16-bit and add it again, it'll be shown as 16-bit in the Cheevo editor. Now, there's a way to override that behavior, simply by using a code node. For example, I can type something like 8-bit in brackets like this, and that node tells the editor to always treat this address as 8-bit, no matter what memory view mode I'm in. So, setting the size is important. Let's move on to Bitflags. These are individual bits in a byte, like switches that can be turned on or off. If I set the size to bit 4, we are reading the 5th bit in that 8-bit value. These are binary values, 1s and 0s, so if I set the value to 0x10, that means bit 4 is on and our condition will match. Now you can also see lower 4 and upper 4 read types. These let you check 4 bits at a time, either the first 4 or the last 4 bits of an 8-bit value. For example, if I set the upper 4 bits to F, only bits 4 are affected. I can enter that value into the value column and the Cheevo will trigger when the condition is met. Now, what does bit count do? Instead of checking for a specific bit pattern, bit count counts how many bits are inside an 8-bit value. For instance, if I set the value to 0xFC, that means all bits except bit 0 and bit 1 are turned on. That's 6 bits in total. So if I set the value column to 6 and activate the Cheevo, it will unlock as soon as exactly 6 bits are on. Now let's talk about how multiple conditions, meaning multiple addresses, work together in a Cheevo. I'll start really simple and from scratch by adding 3 different addresses. The first one will be the score, which is set as 8-bit read size. The second address will be health, set as 16-bit read. The third will be a checkpoint condition with a read size of 32-bit. As you can see in the memory viewer, each of these addresses is highlighted in blue, showing exactly what area of memory is being read based on the data size I've just noted. For example, if I set it to 16 bytes, it highlights a much larger chunk of memory. See how it spans across? But for now, let's just stick with 32-bit read size for the checkpoint. Next, I'll assign some example values for each of these conditions. For the 8-bit score, we are reading 2 hexadecimal digits, so I'll set it to 23. For the 16-bit held value, I'll set it like to maybe 1228. And for the 32-bit checkpoint, let's say maybe 33, 32, 0309 or whatever. Just a special random number. Now I'll activate the Cheevo. The way this works is all these conditions need to be met for the achievement to unlock. So for instance, if the 8-bit score reaches the hex value of 0x23, the hit count for that condition will start counting upwards infinitely. If all hit counts for all conditions are counting at the same time, meaning all the conditions are true, then the Cheevo will unlock. I'll manipulate the memory in real time so you can see this in action. So as you can see, soon as the last condition meets its value, the Cheevo unlocks. Let's dive into the function of hit count, what it is and how it works. So a hit count starts counting when a condition is true. The speed at which counts depends on the game's refresh rate, not the frames per second. In this PS2 game, you can see the FPS counter, but right next to it is the VPS counter. This stands for vertical sync per second, basically the game's tick rate. The hit count is tied to this VPS, so if the tick rate slows down, the hit count slows down as well. For example, here's half speed and here's double speed. Hit count is very powerful. You can use it to build timers for achievements. So say you want a Cheevo to trigger after 5 seconds. You just have to convert that to VPS ticks. Since this console runs at 60 VPS, you just multiply 5 seconds by 60, which gives you 300 ticks. That's the number you enter in the hit count field for your condition. Let me show you that quickly. I'll set the hit count target to 300, activate the Cheevo, and once the score reaches 0x23, the hit count starts, and there you go. After 5 seconds, the achievements unlocks exactly as expected. Now let's talk about flags and operands, which are the core of all of this. We will start with operands first, so I'm going to begin from scratch again. You see this column labeled type? This stands for operands. If I click on mem, a drop-down menu appears, and you'll notice there are 2 columns with similar options, which might seem confusing at first, but there's a reason behind having both, and you'll understand why a bit later. Right now, let's focus on a very important operand called delta. Delta is a key feature that you'll need to include in all of your Cheevos, and here's why. Delta, sometimes referred as a delta check, helps the Cheevo trigger at the exact moment it should. Let me show you an example, and then I'll explain why it's so important. So, if I set the first condition to delta in the left operand column, I need a second condition that uses the same address, but with a different operand type and a target value. I'll just duplicate the first condition using the buttons below, and then change the operand back to mem and set the target value, let's say 0x30. What's happening here is that delta operand will begin its check when the value was previously 0x23. It's essentially watching for the memory value to change to a target value, like 0x30, in a single frame. Still a bit confusing? Let's break it down. Imagine you have 35 coins in a game, then you collect exactly 13 more, and your total coins instantly becomes 48. I'll enable show decimal so you can see it clearly. Now I'll activate the Cheevo. When the value is at 35 or 0x23 in hex, the delta condition is true. Now it's watching for the memory to jump to 48 or 0x30 in hex. And once I manually change the memory value to 0x30, you'll see the Cheevo unlocks. Perfect. Now let me reactivate the Cheevo to show you what happens if delta is not assigned. As you can see, even when I change the value, the Cheevo doesn't unlock. Why? Because without delta, the logic isn't tracking the change across a single frame. It's not even watching for that specific jump in value. With delta, the second condition activates only if the memory changed from 0x23 to 0x30 in exactly 1 frame. I'll reactivate the Cheevo and gradually change the value. First to 0x23, then 0x24, and finally to 0x30. Well, nothing happens. That's because too many frames pass between those values. Delta ensures that there's no delay. It's a strict one frame check. Why is this so important? Because, for example, it helps prevent collectible-based Cheevos from unlocking when a player simply loads a 100% save file. With Delta, the player must actually play and trigger the conditions properly. It won't unlock just because the save file contains the required values. Now let's just stick with Delta and explore the second operand column on the right. Just like the left side, this can also be set to a different operand type. The reason for this is mostly for comparison, comparing memory to memory or memory to value, and sometimes for more advanced logic like polarity checks in complex situations. Let me add another address to show you how this works. The condition I've just added is currently checking if a memory address value is equal to, say, 0x1228. If I set the comparison type to greater than, it will now check whether that address value is above 0x1228. And when I manipulate the memory and set this 4-bit value like from 0x8 to 0x9, the head count starts ticking. Now if I change this right-hand operand to delta, something different happens. The value field switches to memory mode because we're now comparing one memory address to another, not memory to value. If I copy and paste the same address into the right side, what we are now doing is comparing the address to its value from the last frame. So we're detecting whether the current value increased from the previous frame. Keep in mind that you must have delta assigned either here or here for one frame difference check to work. Let me demonstrate. As I increase the value manually, 1, 3, 5, 8, 9 or whatever, you can see the head count incrementing once I change the value. It's checking whether each new value is greater than the previous one in a single frame. If I flip the comparison to less than, now it checks in reverse. If I set it to not equal, it checks for any change at all. So both examples of using delta, either checking for a specific target or comparing frames, are totally valid. The first example is for specific value jumps, while the second one is more about monitoring any changes. Let's apply this to a practical Cheevo example. Say we want to create a condition that triggers when the player collects 48 or more coins. Let me remove the delta check condition because it's not necessary. Now imagine you have to hit an enemy at least 3 times. We'll treat this address as the enemy's health. I'll set the comparison to greater than and set the hit count to 3. Once I activate the Cheevo and manipulate the memory, boom, you'll see the hit count increases each time. Prior works similarly to delta, but it's more efficient in certain scenarios, like when transitioning from level 1 to level 2. For example, it's particularly useful when you want to detect changes between frames and less overhead than delta. Next is BCD, which stands for binary coded decimal. Some older games use hexadecimal values to literally represent decimal numbers. For instance, let's say the on-screen score is 98. Instead of storing it as decimal, the game might represent it 0x98. So BCD allows you to interpret that kind of data accurately when making Cheevos. Invert is basically mem or memory, but it flips the value. This is useful in games where something appears to be counting up on screen, but the memory value is actually counting down. Imagine a level with lots of destructible boxes. As you break each one, the game might count down in memory, even though you're making progress upward in gameplay. Let me explain it in another way. The maximum value of an 8-bit address is 0xFF. Now, if you destroy one crate, the memory might decrease to 0xFE, but instead of writing a condition that checks for 0xFE, you can just type 0x01, which means one crate destroyed. If the memory goes to 0xFD, that's 2 crates, so you write 0x02. If it drops to 0xFC, that's 3 crates. As you can see, the condition becomes true every time you enter the correct invert value. Alright, now for the final section of this video, flags, the most important ingredient that makes a Cheevo more powerful and complex. Let's start with the simpler ones. I'm going to add two different addresses and activate the Cheevo. I'll assign the value 0x01 to both conditions. For the first condition, I'll set the endNext flag. Now here's what this means. The second condition will not operate unless the first one becomes true. In other words, it starts checking only after the first one is true or its hit count has started. Let's test this out. While the Cheevo is active, I'll manipulate the memory and set the second condition's value to 0x01. As you can see, nothing happens because the first condition isn't true yet. Now if I set the first condition, the one with endNext, to 0x01, the second condition becomes active immediately and the Cheevo unlocks. You can chain multiple endNext flags in a row and they will follow this same logic as you can see right here. Now, what about or next? Just like the name suggests, it means check if either this condition or the next one is true. Let's assign 0x05 to the first condition and 0x06 to the second one, then activate the Cheevo. Now, if either of these becomes true, the Cheevo will unlock. I will make the first one true, and as expected, the Cheevo unlocks. Let's do the opposite. And there we go, it triggers. You could even combine endNext and OrNext in the same chain, but keep in mind, if the last condition in the chain is set to OrNext, it can override everything above and cause the Cheevo to unlock, even if the other conditions are not true. This is an expected behavior based on the logic chain. Now let's talk about measured flag. Measured by default tracks hit counts, but it only works if a target hit count is set. Let's say I want to track something like how many bullets the player fires. I'll assign the measured flag to a condition and set its hit target to 10. When I activate the Cheevo, it unlocks immediately. Why? Because this condition is already true and is counting infinitely. To fix that, we need to control it with delta, so that it only counts when the value increases from one frame to the next. Just like before, I'll switch the operand type to delta. Paste the same address here and change the comparison type to greater than. Now when I activate the Cheevo and start changing memory, the hit count increases accordingly, and you can also see your progress as an overlay on the game screen. If I check the track as % option, it'll convert that target into a percentage value. Once the counter reaches 10, the Cheevo unlocks. Now let's talk about AddHits and subhits. I'll copy this condition 5 times, then I'll set each one of them to AddHits and assign a different address to each. The goal here is to accumulate hits from multiple addresses, but we need one more thing, a condition to actually measure the accumulation. This is where a dummy condition comes in. A dummy is basically a false condition. It doesn't check for anything meaningful. Its only purpose is to track and store accumulated hits. To make one, just click Add New, change the operand type to value, and set this one to 0x00 and this one to 0x01, which always returns false. Then set its hit target to 10 and assign the measured flag to it. Now all the AddHits flags will start contributing to that dummy measured condition. You don't necessarily need a hit target to be set to 10 for all of them, as long as the accumulator has a hit target. Let's see that in action. As you can see here, hits are accumulating, and once the troller reaches the target, the Cheevo unlocks. If you want to subtract hits, simply set a conditions flag to subhits. Let's try that out quickly. This condition now subtracts hits, and you'll see the count go down as expected. With all of that in mind, let's see similar flags, add source and subsource. These work similarly, but instead of tracking hits, they track values. For example, I'll set all these conditions to add source. Notice the hit counts disappear, and now the Cheevo is tracking memory values instead. To accumulate these values, you still need to edit the measured condition or the accumulator. This time though, the measured condition's hit target must be set to 0, and the target we want must be set here in the condition's value for it to work. So imagine each of these memory addresses holds a certain value. If all of them added together, they will equal 0x0a, which is 10 in decimal, and the Cheevo will unlock. Let's see this in action. I'll set one address to 0x01 and the next to 0x04, another to 0x02, and one more to 0x03. You can see this in real time. Now the total is 10 and the Cheevo unlocks. Okay, just like with AddHits and subhits, you can also subtract values with subsource. If I set one of these conditions to subsource and give it a value, say like 0x06, it'll subtract that from the accumulator. So if the total was 10 and we subtract 6, the new measured value becomes 4. Now, what if we want to prevent the player from unlocking this Cheevo just by loading a 100% save file? Here's where delta becomes very critical, and here's how we do it. Select all conditions and duplicate them. For the first 5 lines, change the operand types to delta. On the 6th line, remove the measured flag, because only one measured flag is allowed in one group. Set the value on that line to 0x09. Then on the last line, which has measured, keep the value at 0x0a. Activate the Cheevo, and now delta starts tracking the moment values increment from 9 to 10. If that happens within a single frame, the Cheevo will unlock. This ensures it can't trigger from a save file. The player has to earn it in real-time gameplay. And this is why delta is so important, not only for precision but for protecting Cheevos from being cheated. Just keep in mind that delta must be set to all sources for this to work properly, so that each address is a delta to memory. Now let's talk about one of the most important behaviors when using measured, the MeasuredIf condition. When setting up a measured condition, it's strongly recommended, if not mandatory, to also define a MeasuredIf condition. Why? Because without it, the measured tracking could start measuring at the wrong time or wrong level, leading to unreliable progress tracking. The MeasuredIf condition was created to solve exactly this issue, and here's how it works. The MeasuredIf flag, it must be true in order for the measured tracking to begin. Otherwise, the measured indicator won't appear on the screen at all. Let me show you an example. I'll activate the Cheevo and make the MeasuredIf condition true. Now, if I manipulate memory for the add source addresses, you'll see the measured indicator appears. Nice. Next, I'll toggle the MeasuredIf condition to false. Now, if I manipulate those same add source addresses, nothing appears to change, and that's expected because the measured condition is paused until MeasuredIf condition becomes false again. Once I toggle MeasuredIf back to true, the measured tracking resumes in real time, simple and effective. However, things get a little confusing when using AddHits and MeasuredIf. Here's the problem. If MeasuredIf is false and you manipulate memory on AddHits conditions, the hits still accumulate silently in the background. You just don't see the progress on screen. Now, when you set MeasuredIf back to true, the measured indicator picks up the current hit count, not the one it had when MeasuredIf was false, and that can be pretty annoying if you're trying to track accurate progress. What's the solution? Use the PauseIf flag instead. Let's switch this MeasuredIf condition to PauseIf. Now, if the PauseIf condition is true, as you can see, hit counts are frozen, none of the AddHits condition will increment, no matter what I do, until the PauseIf condition becomes false again. And as you can see, that works perfectly. However, this does not mean MeasuredIf can be replaced with PauseIf, because in some situations, the measured condition could still operate. So make sure to put both the MeasuredIf and PauseIf if possible. Now here's something really interesting about PauseIf. It can act as a temporary, persistent, or even permanent pause. Let me explain. If I set the hit count of the PauseIf condition to 1, it becomes infinitely true. Even if the condition is no longer true in memory, it keeps operating as it is. You can try to manipulate memory again, but nothing happens. It's locked. If you check the highlights checkbox, the condition gets highlighted in purple, meaning it's still operating, but as a pause lock state. This is a carried over hit, and it will block the Cheevo from unlocking until you restart the emulator session. That's a problem, but here's the fix. Let's talk about ResetNextIf and ResetIf, starting with ResetNextIf first. I'll add a new condition and move it above the PauseIf line. So the purpose of ResetNextIf will reset whatever condition comes immediately after it. In this case, the PauseIf condition with the stored hit. Now when I make the reset next if condition true, the pause lock is reset and the Cheevo can operate normally again. Perfect. So why don't we just use ResetIf instead? Well, if ResetIf and PauseIf are in the same group, the PauseIf condition takes priority and freezes everything. ResetIf simply doesn't work against it in this case. But don't worry, ResetIf does have a purpose here. Unlike ResetNextIf, ResetIf resets all groups. So here's the workaround. Move all your logic into a new group. Let's call it outgroup 1. Then in your main core group, add a ResetIf condition and set it to value of 0x01. Now watch this. If I make the ResetIf condition true in the core group, you'll see it clears the pause lock and it would even reset the measured hits in alt group 1. Now we could start tracking AddHits again just like before. Just make sure your ResetIf condition is false when you are not actively using it to reset. You can enable highlights checkbox to verify. If it's highlighted in yellow, that means it's currently active. You can think of this ResetIf as a loading screen trigger or some event that resets the logic after level transitions, for example. However, keep this in mind. ResetIf, ResetNextIf, and PauseIf must be implemented only when the group has a stored hit condition, like measure that tracks hit targets and conditions that has stored hits. That's the purpose of using them. Otherwise, don't touch the hit count and leave it as default unless the plan of your Cheevo insists on it. Now, let's talk about the trigger flag. Probably the easiest one to understand, but one that can still trip you up if you are not careful. Let me show you an example. I'll add 3 different adders conditions and assign the trigger flag to the last one. Now I'll activate the Cheevo and start making these conditions true. As soon as the second condition becomes true, you'll notice something appears on screen, and the state in the asset list changes from active to primed. This means the Cheevo is waiting for the trigger condition to be fulfilled. It means you've met all other conditions, and the trigger is the final step to unlock the achievement. Now, what's the purpose of this? Think of it like this. The first condition could be a level ID, the second might represent reaching a checkpoint, and the third, the trigger, could be the boss's health reaching 0. This setup, especially when the trigger indicator appears, notifies the players that they have entered a challenge, and if they complete the final condition, the boss's health reaching 0, the Cheevo unlocks. But what happens if we fail the challenge? That means the Cheevo should reset, and players will have to try again. Let's add another condition, for example, player health at 0x03, and this will act as a fail condition. If the boss hits me and my health drops to 0x02, that means one of the main conditions is no longer true. Now, if I manipulate the memory, the achievement indicator disappears. Perfect, that's exactly how it should behave. But here's something I learned the hard way. If I assign any flag to any of these conditions, say the player health condition for example, let me assign AddHits, the Cheevo indicator appears again. Why? Because the trigger flag ignores any condition with a flag when checking if all conditions are true. It only checks the flagless conditions. So if all non-flag conditions are true, the achievement is considered primed, waiting for the trigger to fire. You can also assign the trigger flag to multiple conditions. This means the Cheevo will only unlock when all trigger conditions are true. So for example, if I now assign trigger to both the boss health and the player health conditions, both must become true for the Cheevo to unlock. Let's see that in action. And there you go. It works exactly as expected. I'll be covering the rest of the flags in the next part of this video, as they require a more practical way to explain them. I hope you've picked up something useful from this part of this video. If anything still feels unclear, you are always welcome to read the official documentation and then return to watch this video again. This video is intended to be a practical companion to the docs, and all the deeper details are covered there. Have a good day and see you in the next one. Cheers!